In this video I'm going to talk about leaves and trees. So this is like in graph theory. A reminder that the definition of a tree. So a tree is a connected graph without cycles. So then a definition of a leaf. So a leaf in a tree is a vertex of degree 1. And now the main statement of theorem. So any tree contains at least one leaf. So we are going to prove it by contradiction. So let's suppose that the statement is not true. Suppose that it is not true. So then it means that any vertex in our tree has degree at least 2. So for any vertex in the tree, the degree of this vertex is greater or equal than 2. So this means that okay, so we are going to construct a path in the tree. So let's start with an arbitrary vertex V. Not V, like not going to denote it. Let's start with an arbitrary vertex. So then so it has a degree at least 2, right? So but in particular it has an edge connected to it. So we go by this edge to another vertex. Then so we move like this. So this vertex it has degree at least 2, therefore except for this edge by which we arrived to it, it has at least one other edge incident to this vertex, right? So we can go by this new edge to another vertex. Then when we arrived here, because the degree is at least 2, so one edge is here, but because it's at least 2, there exists at least one other edge incident to this vertex. And we go by this edge. And so we continue like this. And so at every step, when we arrive at the vertex, we always can go to another vertex. So because there are only finite number of vertices in the graph, because there is only finite number of vertices in the graph, sooner or later we will visit a vertex that was already visited, right? So let's say that okay, so let's write this. So because there is only finite number of vertices, at some point we will visit a vertex that we already visited, we already visited before. So now let's take the first time that this happened. So take not let's write it another way. Not let's take, but let's stop. So we stop the first time that this happened. So we stop when this happened for the first time. When this happened for the first time. So what this means is that so let's go back to our picture. So we visited a number of vertices, and then so let's say for the first time we arrived at a vertex that we already visited before. So we started here, we went here, like this, and now we arrived here that we already, it doesn't have to be the initial vertex where we started, like it can be somewhere in the middle, but this happened for the first time. So now we stop and we say that so we remove all the path previous to this vertex before we first visited this vertex, and starting with this vertex that repeated for the first time, and going along the path like this. This is a cycle. So this would be a cycle. And this is a contradiction because there cannot be any cycles in a tree. By definition, a tree is a connected graph without cycles. So the fact that we found a cycle, it contradicts to the fact that it is a tree. So this is a contradiction that concludes the proof.